really unusual, me recording myself and hopefully you guys listening and understanding everything that we're doing. We are going to start chapter 8. We're starting with section 8.1 on inverse variation. So just follow along, take your notes as if you were in class with me. And then at the end, if you do have any questions and you're still confused about something, maybe try to email me and I'll help you out. Okay? All right, so let's start. We're going to start with something called direct variation. Direct variation we actually learned in section 2.2 back in the first semester, like in September or so. Okay, and we learned with direct variation that we had y equals kx right here. Y equals kx meant we had direct variation. Think of like y equals mx plus b, right? But b was always 0. And so something like y equals 2x, or y equals 1/2 x, or y equals negative 3x, okay? Your k was not equal to 0. And what always happened is that in direct variation, as one quantity increases, as your x increases, the other one also increases, your y increases. Okay, so that always happens. It also happens if x decreases, then y will be decreasing as well. Okay, so they're both either increasing or they're both decreasing, your x's and your y. And we also learned that when we did direct variation, we had y equals k times x, and from this we learned that if we solved for k, that k was equal to y divided by x. So we could find our constant k, called the constant of variation, by taking all the y's and dividing them by all the x's, and we'll do that in just a moment. Okay. Well, now we're going to add a new type of variation to this. We are going to talk about inverse variation, okay? And inverse variation has the form y equals k divided by x. So instead of y equals k times x, y is equal to k divided by x. And if we solve for k here, if I solve for k by multiplying by x on both sides, we would get k is equal to x times y. Okay, so your constant and a variation can be found, the k can be found by multiplying x and times y, and you'll have your constant of variation. Now, when you have inverse variation, what we have with our x and our y's is they vary inversely, and as one quantity increases, the other one decreases now because they're inverses of each other. So as x increases, y will decrease, or as x decreases, y will increase. Whereas with direct variation, as we said, they either both increase or they both decrease. So that's the difference, okay? Inverse is going to be one's going increasing and one's decreasing. And again, we call that k our constant of variation. And sometimes it's going to ask us to tell them what the constant of variation is. So if we look at this first example, it says, is the relationship between the variables a direct variation, an inverse variation, or neither? We are going to write the function model for the direct and inverse variation. Okay, so if I look at this function model here, I have that my x's are going from 2, 4, 10, and 15. So I can clearly see here that we are increasing. Let me pick a different color. I don't like that color. Okay, so we are increasing here. Okay, and then my y's now, 15, 7.5, 3, 2. We are decreasing. Oops. I really need to get that Apple Pencil, you guys. Okay, we are decreasing. Okay, so increasing and decreasing. That tells us it cannot be direct variation because direct variation is both increasing or both decreasing. So it's a possible inverse variation, okay? So we're talking about the possible inverse variation. Now we just need to confirm that it's inverse variation, okay? So we have possible inverse. And we're going to confirm if it's inverse variation. And the way we're going to do that is by seeing if every x times y pair, we're going to see if every x times y pair is equal to the same k. hold on. My stylus is not working. That's better. Okay, so that's how we're going to do it. We're going to check every x times y. So we're going to say, okay, x times y, and we're going to multiply them, and it's going to equal a number k. And if the number k is the same for every single ordered pair, then we have inverse variation. So we're going to take 2 times 15, and we'll see that it equals 30. We're going to take 4 times 7.5, and we see that it equals 30. We're going to take 10 times 3, and we see that it equals 30. And we're going to say 15 times 2, and it will equal 30 as well. And so this 30 is our k value. You can see here that every k is 30. And so what we do have here, because they are all the same, we do have inverse variation, okay? Our k value is equal to 30. And then when it asks you to write the function model, it wants the equation. That's what it wants. So our equation is y equals k divided by x. And so we say, okay, y equals 30 divided by x, because we found our k to be 30. All of these right here are our k values. And so that's our answer. It is inverse variation. K is equal to 30, and our function is going to be y equals 30 divided by x. And you can always check your work. You can always plug in, let's say x was 2, so 30 divided by 2, y would get 15. And so you see that ordered pair there. And so all of these ordered pairs fall into that function. Okay? And so that is inverse variation. Okay? As we go on to the next one, okay, we're going to do the same exact thing. We're going to look to see if it's direct, inverse, or maybe neither. Okay, and so we're going to look here, and I see, okay, my x's 2, 4, 10, 15. I see that they're increasing. And then my y's 10, 8, 3, 1.5. Again, they are decreasing. Okay, so again, because it's increasing and decreasing, we have a possible inverse variation. Okay, that's going to be the question. So it's not going to be direct variation, because direct is either both increasing or both decreasing. Okay, so we're going to check all the x times y's and see if they're all equal to the same k. So 2 times 10, we get 20. 4 times 8, we get 32. And we can actually stop right there. Once one of them is different, that means it doesn't work. Okay, I mean, I could show you the rest. 10 times 3 is 30. 15 times 1.5 is going to be 22.5. Okay, but it only takes one to be different. So because you see that they're all different k's, we are going to have neither. It was not direct variation because they were not both increasing or both decreasing. Okay, and then it didn't fit into the inverse variation where x times y is equal to k. And so it has to be neither. And when it's neither, we do not have a function for it. Or a k value or constant of variation, we just write neither, and that's the end. Okay. All right, now the got it's here. Okay, we're going to try this one here. And if I look at my x and my y's, my x 0.2, 0.5, 1, 1.5, that looks like it's increasing. Okay, my y's 8, 20, 40, 60, this looks like it's also increasing. Okay, so both are increasing. So we have a possible direct variation now. Okay. And so then for a direct variation, what we are going to check is all the y's divided by x's equal to k. Hold on, let me erase that. So I'm checking to see all the y divided by x, if they're all equal to the same k. So I would check 8. Make sure you check the 8, the y divided by the x divided by 0.2. Okay, and we see that it's equal to 40. And then I do 20 divided by 0.5, and I see that it's equal to 40. It only takes one, though, so you need to make sure you check all of them. And then I check 40 divided by 1 is 40. And then 60 divided by 1.5, and I also get 40, okay? So I see that they're all the same. All our k values are 40, so we do in fact have direct variation, okay? And what we have is our constant is equal to 40, and then our equation now for direct variation is y equals k times x. Okay. And so with our k equal to 40, we have y equals 40x. And that is our answer here. Oops, I should circle all of that. All of that is our answer. Direct variation, constant is 40, and our equation is y equals 40x. Okay. Now try to pause right now and try to do, let's do D. Okay, go ahead and pause and do D on your own and see if you can get the answer that I'm going to get. Okay, I'm going to pause it as well. Nope, I'm not, just kidding. Okay, so if you paused it, I'm just going to go through this one fairly quickly. And so I see that 0.2, 0.5, 1, and 2, okay, we're increasing for x. And then 40, 16, 8, and 4, I see I'm decreasing for y. So I have the possibility of inverse variation. And in inverse variation, I see that x times y must be equal to k for every single one. And so 0.2 times 40, I get 8. 0.5 times 16, I get 8. 1 times 8, I get 8, and 2 times 4, I also get 8. So on all of these, I get a constant of 8, so it is in fact inverse variation. My constant is 8, and my equation y equals 8 divided by x now because it is inverse variation. So your function is going to be y equals 8 divided by x. So make sure you take a look at my pink right on the left side here. We have the direct variation, the equation's y equals 40x, where my inverse variation y is equal to 8 divided by x. So there are two different equations. You get your constants differently, and also notice again with direct variation they're both increasing. So if you look at my pink here, okay, both the x's and the y's are increasing. That's why it was possibility of direct variation. And then on the purple for example D, you had one was increasing, one was decreasing, and that's why it's inverse variation. Okay, under possible inverse variation, which turned out to work. Okay. All right. Now on to the second part of this. The second part's going to include some graphing. Okay. So, determining an inverse variation. We're going to stick with inverse here. So, suppose x and y vary inversely. So, you already know they vary inversely. You don't have to check to make sure they are. And they tell you x equals 8 and y is equal to 7. Okay? Well, if x is equal to 8 and y is equal to 7, okay, then we know that x times y is equal to k. So, 8 times negative 7, it was a negative 7 earlier. It is equal to 8 for x, negative 7 for y. Multiply those and we get a negative 56. So this is our k value. So my function, it's going to model y equals k divided by x. And so that's y equals negative 56 divided by x. And this is my equation here. This is my function model. Okay. And so the question is, what does the graph of this function look like? So we're going to graph these, and the only way we're going to graph these right now is through a t-chart, just making a table. Okay, so we're going to come over here. We're just going to make your normal XY table, and we're going to pick some x's, and we're going to plug them in. And then we'll find the y's and we'll graph them. Now the trick here is make sure you pick positives and negatives, okay? And the numbers you're going to pick are going to be numbers that in this case divide into a 56, okay? You don't want to pick a number like 5 because it's going to give you a fraction. Negative 56 divided by 5 is going to be negative 11.2, and we don't want to deal with that. Okay, so you only pick numbers that divide into 56, all right? So, for instance, the easiest one 1 divides into negative 56, and we get a negative 56. Okay, I could take 2. 2 divides into negative 56, and I get a negative 28. Okay, those are all like numbers, but as you can see, they're very, very big. Okay, so we don't need to go through all those numbers. I want you to see that there's other numbers that are going to be better, maybe like 7 and 8, right? 7 divides into negative 56. Come on. And it goes in negative 8 times. So does 8. 8 divides into negative 56, and it goes in negative 7 times. Okay. Now, those are my positive x's. I'm also going to take these numbers. I'm going to do negative. Okay. So I'm also going to do negative 1, negative 2, negative 7, and negative 8. So whatever numbers you pick that divide into 56, make sure you're picking the positives and the negatives. Okay. And so negative 56 divided by negative 1 is 56. Negative 56 divided by negative 2 is going to be positive 28. Negative 7 into negative 56 is going to be positive 8, and negative 8 into negative 56 is positive 7. Okay? And so we have our t-chart, okay? You'll notice I did not pick the value of 0, okay? I feel like we always pick 0, right? The problem is whenever x is equal to 0, so anything on this line right here on the graph, okay, we get an undefined fraction. Negative 56 divided by 0 is undefined. And so what we have here with my orange line for the y-axis, that's where x is equal to 0, okay? We call that an asymptote. We'll learn that a little bit more about that in section 8 too. And it turns out that you can't plug in x equals 0, but y will also never be 0. There's no number that I can plug in for x that's ever going to make it 0. Okay, so like as you saw, 1, 2, 7, 8, nothing made it 0. I can't plug 0 in. Nothing comes out as 0. Okay, and so what we have here is that none of the y's can be 0 as well. And so those two axes, the x-axis and y-axis, we call them horizontal asymptotes and vertical asymptotes. And we're going to learn more about them in the next section. For now, let's just go ahead and plot our points, okay? So negative 156 is going to be really, really big. Negative 228 is going to be really, really big. Negative 7, comma 8. 1, 2, 3, 4, 5, 6, 7. And then... oh, sorry, negative 8, comma 7. That's what I meant to do first. 1, 2, 3, 4, 5, 6, 7, 8. And then negative 7 will be somewhere up here. Come on. Just trying to, there we go. And then negative 7, 8 will be somewhere up here. Okay. And then 1, negative 56, 2, negative 28, those are also really big and off the graph, so I'm not going to plot them. And then 7, negative 8, so I'm going to go 7, negative 8, and then 8, negative 7. And right now it's really hard to look because there's not a lot of points, but it does make a curve, oops, like this. And then this curves like this. And as we do more of these problems with like different kinds of numbers, that's how it's going to be. It's going to be two curves, one on opposite corners. Okay, so we'll see more of this. Negative 56 was a really big number. Sometimes we have to deal with those, okay? But let's look at when we look at the next problem, you'll see the numbers aren't that big. Okay, before we go on to the got it, what is y when x is equal to 2? That's the question. So the equation is y equals negative 56 divided by x. So let's plug in x is 2 here. We get negative 56 divided by 2, and we get y is negative 28. And we're done with that. So sometimes they just want to know what's the value when you plug in a number. Okay? All right, the last one we're going to do for today, you don't have to worry about anything else after this, is going to be this got it. Go ahead and pause your screen and I want you to try, okay, create the equation, find the constant by finding the constant, and then graph using a t-chart. That's all you're really going to do here. Okay, so go ahead and pause it and then come back and see if you got it correct. Okay, so I'm going to run through this kind of quickly. We want to know what is the function that models this inverse. So in our equation, we're going to have that x times y is equal to k because they vary inversely. And so that's 4 times 12. And that's equal to 48. Okay? And so our equation is y equals 48 divided by x. Okay, that's our inverse variation function. Okay, and so now we're going to make a t-chart. We're going to find numbers that divide into 48. Okay, and so yes, 1 goes into 48 48 times, 2 goes into 48 48 times, 3 goes in 16 times, 4 goes in 12 times. I'll pick 4. 4 goes in 12 times, not 5. 6 goes in 8 times. 7, 8 goes in 6 times. Those are some good numbers, okay? And then if I'm doing the positives of 4, 6, and 8, I'm also going to do the negatives. -4, -6, and -8, okay? So again, I'm picking numbers that divide into 48 that aren't going to give me huge values, okay? So yes, 1 goes into 48, that is true, but then you're going to end up with 48. Okay, so it's a really big number. I don't want to deal with that on my graph. Okay, I can't pick 0 because 48 divided by 0 is undefined, so I'm not picking those values. -4 into 48 is going to be -12. -6 into 48 is going to be -8, and -8 into 48 is going to be -6. And so then we're going to graph these. You don't have to draw these at the moment, but we will learn about that again. These are our asymptotes. We will never cross these asymptotes here, okay? So -8 divided, -8, -6 is going to be right about here. 1, 2, 3, 4, 5, 6. -6, -8. 1, 2, 3, 4, 5, 6. And then -4, -12. 1, 2, 3, 4. I'll just make it kind of like right around here. Okay. And so we have a curve for the negative side. Okay. And then we have 4, 12. 1, 2, 3, 4. Maybe something up there. 6, 8. And then 8, 6. And then we have our other curve over here. Okay, and again, these inverse variation graphs will always look like that. Okay, the last question, what is y when x is equal to 2? So y is equal to 48 divided by 2. We plug that in, and we get a value of 24. Okay. So that is it for 8.1. That's our first section. Hopefully you are able to understand everything. We are not going to do the page 3. We're kind of just going to keep it simple in our notes, in our homework. We're going to do a little bit less than we would do in the normal classroom, unfortunately. But hopefully you guys understand that. You can try the assignment, and if you have any questions, don't hesitate to email me. Talk to you guys later. Hope you're doing well. Bye-bye.